So this is the second application problem we're looking at in this section, a little bit more complicated than the first one. An airplane is flying 10,500 feet above level ground. The angle of depression from the plane to the base of the tree is 14 degrees. How far horizontally must the plane fly to be directly over the tree? And for this problem, we join the Flat Earth Society. We're going to assume the Earth is flat. Now, you'll see this phrase angle of depression occurs in this problem, and it's really crucial that you understand what angle of depression means. And there's really just one fundamental fact to get down, and then you'll never have trouble with it. And I wrote this on a yellow card. I'm not sure it merits its own yellow card, but sometimes we talk about angle of depression, sometimes we talk about angle of elevation, but in either case, one side is always horizontal. So when you're drawing a figure to represent a problem, the angle of depression or the angle of elevation referred to has to have a horizontal side or something's wrong. And if you just remember that, you'll be okay. That's the main thing to keep track of here. So let's see if we can draw a picture to describe this problem. So we got the ground here, horizontal. We have this airplane up in the sky, 10,000, we know it's 10,500 feet high. And off in the distance there's just this tree somewhere. So maybe that's a little high for a tree, but there's my tree. And the angle of elevation from the plane to the base of the tree. Now I know I'm drawing a line something like so. And it's tempting to label this angle that I'm indicating here, but there's no way that can be an angle of depression, because for an angle of elevation or an angle of depression, one side must be horizontal. So what I can do is I can just draw possibly a dotted line this way, or a line. This is where the 14-degree angle is, right here. Okay? Because it's one side horizontal, one side is descending down toward the base of the tree. And then we want to know, how far must the plane fly to be directly over the tree? Well, we could just extend this line to where it's directly over the tree. And you might say, that's what we're trying to find, that distance x. And there's actually a couple of right triangles in this picture. In fact, if you see this as a rectangle with a diagonal, those two right triangles, either this half or this half, have the same dimensions, are congruent, they have the same angles. But just make sure you realize that if this angle is 14 degrees, it's this angle, you don't necessarily need to draw it, but this angle would also be 14 degrees. It's not these two angles that match up, right? It's like alternate interior angles in geometry. This side, this length here, is also 10,500 feet, right? Because we have a rectangle. You could also use this lower triangle because the distance along the ground would be the same as the distance up in the air. So let's see, if I just pull out a triangle to use here, say I use the upper triangle. I got 14 degrees, I want to find x, right angle here, 10,500 feet here. For 14 degrees, I have an opposite side and an adjacent side involved. I think I want to use tangent in this problem, my TOA. So tangent of 14 degrees is going to be opposite over adjacent, so it's 10,500 over x. I got to be a little bit careful now because I have x in the denominator in solving this. I can't just divide by 10,500, right? Because x is in the denominator. And again, I can leave that expression tangent 14 degrees if I'd like, or I can figure out the decimal later, or I can go right ahead now on my calculator and do tangent 14 degrees. I'm going to do it now, round off at 4 places. So I get 0.2493 is technically approximately equal to 10,500 over x. Then what I want to do is I'm going to multiply both sides by x, right? So that x cancels on the right, and I get 0.2493x equals 10,500. And then I can divide both sides by 0.2493. And so if I take 10,500 divided by 0.2493, I'm going to round this off to the nearest foot. I'm getting 42,118. 42,118 feet is how far the plane has to travel horizontally. And you don't need to take it further than this because I didn't ask you to change units or anything. But if you divide by 5,280, how many feet are in a mile? It's approximately 8 miles, but that's not at all required here. Okay, so we got our airplane problem. There's the statement of the problem. Our picture, the thing to be most careful about is angle of elevation, angle of depression, like we said, and there's the final result.